GATE 2018 Civil Engineering Set 2 Question 37. The value of a line integral over a curve C FR for FR equals x square I cap plus y square j cap along C, which is a straight line joining 0 0 and 1 1 is. The relevant NPTEL reference has been cited. When we want to evaluate the integral of a function f of r vector dr vector and it is taken as a dot product, let us assume that fr vector is of the form fx I cap plus fy of j cap. So taking this fx into I cap plus fy into j cap, this should be taken as a dot product with dr vector. So dr vector would be nothing but dx I cap plus dy j cap. Taking this here, which will be dx I cap plus dy j cap. On taking the dot product, what we do is we multiply the I components together and add them with the product of the j components. This would be integral over C fx into dx plus fy into dy. Depending upon the points that are given from P1 to P2, we can split this integral between C fx dx from C at point P1 to C at point P2 plus integration of fy dy C at point P1 to C at point P2. We can split the integral and evaluate the individual integrals, which are I1 and I2, to get the combined integral, that is I. This function may also get complicated sometimes and may be given as f of xy, where the same function will be implicit in x and y together and the second function will be g of xy. In those cases we need to resolve it, and then we need to apply the relationship between point P1 and P2, which may be a straight line or a parabola depending upon the particular situation. In this case we have been given fr vector as x square I cap plus y square j cap. Point P1 is given as 0 0 and point P2 here is given as 1 1. The relationship is of that of a straight line between these 2 points. It means if we visualize this on the coordinate system, this will be point P1 0 0 and point P2 will be somewhere here, that is 1 1. So if we join them using a straight line, we can see that the relation will be y equals x. So the integral that needs to be evaluated over the curve C, that is the line joining P1 and P2, is fr vector dot of dr vector. So integral over C fr vector, that is x square I cap plus y square j cap, taking its dot with dr vector, that is dx I cap plus dy j cap. We multiply the I components together and j components together and then add them. This would give x square dx plus y square dy. Now we can split the integral in x square dx plus integral of y square dy. We can see that the value of x at point P1 is 0 and the value of x at point P2 is 1. So we can impose the limits from 0 to 1. Similarly, the value of y at point P1 is 0 and at point P2 is 1. So similarly, imposing the limits as 0 and 1 for y, the integration would turn out to be x cube by 3, 0 and 1 are the limits, and y cube by 3, 0 and 1 are the limits. Imposing the limits, we would get 1 by 3 into 1 minus 0 plus 1 by 3 into 1 minus 0, which would turn out to be 2 by 3, that is 0.666. This can be rounded off to 0.67. That is our final answer. So the value of the line integral along the curve C, which is a straight line between 0 0 and 1 1, was found out as 0.67. The relevant NPTEL reference has been mentioned.